In this video, I'll be doing a detailed solution to the maths question you see on the screen here from the Cambridge A-Level Mechanics paper 4.3 from 2024. If you're looking for a different question from this paper or a different paper entirely, check out the description below. And if you find this or any of the other videos on my channel useful and would like to help me out, the best thing you can do is share it with other people doing the exam. Perhaps if you're in a class WhatsApp group, share it there. Failing that, a like, subscribe, or even a super thanks. In question 2, they give us a diagram that looks roughly like this, telling us a lot of information about it. Let me try and demonstrate what they're telling us here. We have a wall that this string and a weight, the weight is, I don't have it there, 0.2 kilos. So it's hanging here, but there's some force, this X force here, holding it up, just enough that it doesn't fall. If X wasn't there, it would swing back into the wall. That's the situation we have here. They want us to know is what's the value of X and find the tension in the string. Remember, this is a string. This is not a string, that's just a force arrow. That's a string there. What's the tension in the string? Okay, to do that, let's set up a force diagram. Let's put it down here. Here's the point. What's all the forces acting on it? We have gravity. And actually we have an exact number for that. That's mass times gravity, which is about 10. So 2. I say about 10, it's 9.81, but in mechanics we just use 10, much easier to deal with. 2 newtons going this way. We have this X force here, it's fun to say that, X force, going that direction. We've one more force on this, the string. Anything being held by a string, it's holding you back. The string is pulling you. You might be pulling it, it's pulling you back. So we have a force going up here. We call that T, tension. Whenever you're dealing with force, they tell us this is all in equilibrium. That means overall there's no force. These should all cancel down to 0. So whenever you're dealing with this situation, just add all the forces together. To do that, we move them all into the same direction. You could move all these, the T force could go up, T could go left. That's let me put T on both of them, even though it'll be T cosine, T sine, certain angles. The X force could go this way and another one up there, X and X, and 2 could go down. You could do that if you want. That would just mean breaking up 2 of these forces. So much better to leave X alone, leave T alone, and we're going to break the 2 up. It's going to go this way and this way. We're going to break that forces up. So we need to break this up. Let's put it in on this original one too, and put a dotted line this way, a dotted line that way. So this force, we're going to use this rectangle here. So we need to know the angles involved. I want this length or this length, they're both the same, and this length or this length, both the same. So we need to know where is 30, we know 30 degrees is in here, but just where is it? Be careful. That's 30, that's 90. If this is 90, this is 90. Yeah, this is a much easier way to do it. This is parallel. This line down and this line down are parallel. If that's 30, in there is 30. So we have a 30 degree angle. I want this length, that's opposite this angle. So this length here, or this one here, is sine. That's 2 sine 30. Remember, sine 30 is an easy one, it's just a half. And this one then must be the other. It's the adjacent one down here. So it's cosine 30, which is square root 3 over 2, I think. We'll let the calculator do all that for us. Okay, these are the only forces. This is isn't too bad of a question now. This direction equals that direction. That direction equals that direction. It's not actually too hard here. They wanted X. Well, good, because X must equal 2 sine 30. Put it in a calculator, but like I said, sine's a half. This is just 1 Newton. Must be the X force that's holding this up. They wanted to know the tension. Well, tension must equal the thing that's opposite it there, 2 cosine 30. Like I said, I think that's square root 3 over 2, which would make it square root 3. There it is. Yeah, square root 3. Okay. Square root of 3 newtons, or you could put square root of 3 in and get 1.73 newtons. And that's it. That's the answer to this question. You could do this way as well. You just would have ended up with a simultaneous equation. You would have had 2 is equal a half t and square root of 3x and so on the other way. It would have just taken a little more time. So always keep an eye out that in forces. Do as little work as you can. Or sometimes you do a little more work to make it easier. But still, it worked out much easier to solve it this way. Okay, if you have any follow-up questions, let me know in the comments. I'll do my best to answer. Thanks for watching and have a great day.